Okay, now that you know how to graph basically sine and cosine with the 5 important points, let's have a look at being able to do a slightly different graph. Say we wanted to do a graph of y equals, say, 3 of sine x. And how would that look? This 3 right here, this is new. This was not anything that we had in our graph before. We just graphed y equals sine of x in the last video. So what does the 3 do to the graph? That's the question. Well, what the 3 does is it multiplies whatever sine of the input is. So for example, and again, I don't in the end want you working with tables, but it's a good place to start in understanding what is going on. So if my function is sine of x and I put in, say, 0, then what I'm going to evaluate is 3 times sine of 0. But as you guys know, sine of 0, this value right here, sine of 0 is 0. So this overall is the same thing as saying 3 times 0, which is 0. So again, these are creating points on your graph. So I would plot the point 0, 0 to correspond with my work at right here. Okay. Do you guys remember in the last video how we started our x-axis was we walked 8 spaces to the right of the origin? Well, I'm going to do that again. 1, 2, 3, 4, 5, 6, 7, 8. I make a little tick mark here. And just in the last video, we call that 2 pi. 1, 2, 3, 4. This is halfway in. This tick mark would be called pi. Halfway in from that, that would be pi over 2. And halfway between pi and 2 pi is 3 pi over 2. So make sure to mark your x-axis, just like we did in the last video. Now, what will happen is this, that when I get to my highest point, which happens at pi over 2, so remember that sine of pi over 2 is 1. So if I wrote 3 times sine of pi over 2, do you guys see that the sine of pi over 2, as we just said, is 1, but 3 times 1 makes 3. So we're going to get 3 as our value, and therefore the point on the graph is pi over 2 comma 3. So this is creating a higher graph. It goes up higher and it's going to go down lower. So I will mark this value right here, not with a 1 this time, but with a 3. This is going all the way up to 3. That's the highest it's going to go. I'm going to go just like before, baseline, high. And remember in the last video, we said you always go on sine, baseline, high, baseline, low. Well, how low is that? Well, it is going to go down to -3. So its amplitude, the amplitude of this graph is 3, which means it goes up to 3 and it goes down to -3. I'm connecting the points, the 5 points in the nice smooth curve. And it looks like what I've just graphed is y equals 3 sine of x. So remember in my last video, my graph would only go up to 1. So this would be the height of 1, and this would be -1. And my sine curve would go up to 1, would go back to baseline, it would go down to -1, and would come back to baseline. All right, so what I just graphed in black was the graph that you already learned, and that is just y equals sine of x. There's a thing called amplitude, and the amplitude is how much the graph goes up and how much the graph goes down from baseline. So I call the x-axis baseline, and however much the graph goes up or down from baseline is the amplitude. So notice that this graph, this one that I graphed with y equals 3 sine of x, it goes up 3 units, and that is the amplitude for this graph, and it goes down 3 units, and so what we say is that the amplitude is 3. All right, so the amplitude is always positive. You'll never quote it as negative. And the amplitude for y equals sine of x is just 1. So that describes what amplitude means. Let's look at cosine. So cosine, suppose that I did this and I just said 2 cosine of x and we want to graph that. So again, let's remember how we graph. We go out 8 spaces from the origin. 1, 2, 3, 4, 5, 6, 7, 8. What do we call that? 2 pi. Then come halfway in from that. 1, 2, 3, 4, and call that pi. Go halfway in from that, divide pi by 2, and call it pi over 2. And go in 3/4 of the way in, or halfway between pi and 2 pi. That's 3 pi over 2. Now, what are you going to mark the y-axis? I'm going to mark it 2 and -2, because as you can see, my amplitude has changed to 2. So I definitely need to mark my y-axis with, it has to go up 2 from baseline and down 2 from baseline. So do you remember how cosine goes? Cosine starts high, it goes baseline, it goes low, then it goes back to baseline, and then it goes high. I'm graphing one cycle of cosine, and that's all I need to do. I don't need to create any tables. I just need to remember how cosine looks through those 5 points, and this is one cycle of cosine. This graph has amplitude of 2, and I'm done with that. All right. Well, let's also consider the possibility that I could give you guys a slightly different problem, and that is I can put a negative on that number that's multiplying the sine or cosine function. So let's have a look at how that would go. Suppose that we start out with by doing, I just totally crossed off my axes, so what I'm going to do is come down here and try not to do that on this one, and we'll start with talking about this negative on the front. So let's do this. How about if we had y equals -2 cosine of x? Suppose that this was what I wanted you guys to graph. And you guys said, wait a minute, what is that -2 going to do? Well, this time my graph, again, it will have amplitude of 2. However, what I want you guys to do is adjust so that all of the high points go low, all the low points go high, and the baseline stays baseline. And let's look what that would look like. So this point that's high, it would go low. Baseline stays baseline. The low point goes high. Then you have baseline, and then you have low. So if I were to graph this, then I would connect up these points in a smooth curve, and my graph over one cycle would look like so. So this is what we call a reflection through the x-axis. Okay, so my graph is showing a reflection because that number has a negative on it that is multiplying my cosine or sine function, and that's what creates the reflection. What is the amplitude of this graph? And remember, amplitude is simply how much it goes up and down from baseline. So my amplitude is still 2. Amplitude is never negative. So always quote your amplitude as a positive number. And so that's what I have for the graph of -2 cosine. All right, so suppose that I wanted to create another graph, and this will be for y equals, say, -3 sine, about -3 sine of x. So I'm trying to recreate something here to work with. All right, so we are graphing y equals -3 sine of x. How do we do it? Now remember, it's just 1, 2, 3, 4, 5, 6, 7, 8, and we mark that 2 pi. Go in 1, 2, 3, 4, mark that pi. Halfway in from that, pi over 2. Halfway in from that, 3 pi over 2. Okay. What am I going to mark the y-axis? Well, 3's, right? Go up 3, 1, 2, 3, and call that 3. Go down 3, 1, 2, 3, and call that -3. So, how do we do the rest of the graph? Well, remember how it goes? Baseline, normally it would go high. Remember how it normally goes high, but it will go low because this is a reflection because of the negative. So instead of baseline high, you'll go baseline low. Baseline, okay, now we go high, and now we go baseline. Do you see how this is a reflection through the x-axis of what you're used to seeing for sine? Okay, so I just am trying to graph that like so. Let's remember how the graph is when it's a +3. When it's a +3, it'll go like this, and it would just look like the reflection of each other through the x-axis. So I'll just write here what I just graphed in blue is y equals 3 sine of x. All right. So whenever you do a reflection, the highs go low, the lows go high. Okay. So you get the idea, and what we have here is a graph of the reflection, y equals -3 sine of x. I hope that helps you guys. And now you know a little bit about amplitude and reflection and the basic graphs, sine and cosine. All right, good luck.